Tim Kern. I'm an aviation journalist, and I'm interviewing Sam Bousfield, and he is the inventor and force behind the Samson flying car. Here we go.
Yes.
Why did you decide to do a thing like this?
Pretty crazy, I know. At one time I was working with some Boeing engineers on a new way to push an airplane through the air with a propeller. Our goal was to break the sound barrier with a prop, which had never been done before in level flight. So we went, we can do this. And I worked for years on that project. Had it up to where Steve Fawcett was interested in doing the project along with Breitling as a watchmaker to push it through so we could break about 19 world records. And what I found was, he had the strong interest. Right at that point is when he had his accident. So he stopped in that line before we could get to our project. And I was without a way to move forward. So I looked at aviation and I went, well, I could go on the cutting edge, but what does aviation really need? And what I saw it needed was a way to make it more practical, more useful, something that you could do on a day-to-day basis, make it work for you. And so I designed the SwitchBlade as the first step towards that. And that's where we got going.
And how did you get into aviation in the first place, though?
I think I started in aviation when I was probably about 4, when I got my first flight up in a plane. There was those old days when you could go to the airport and I think it was a penny a pound. They would fly you and you could go off on the planes and it was just great. You get up there and white knuckle looking over the edge, but after a while it got to be, too good to set aside.
And do you have an engineering background then, or is it practical experience, or what did you bring to this?
Yeah, the practical experience I have is mostly in architecture and in my ability to create and think outside the box. I think that's the biggest thing that I bring. The SwitchBlade isn't really new technology so much as a repackaging, and the repackaging is what makes it work. The package that we came up with, 3 wheels, both ground and the air, the rear CG for the ground use, and also keeping a nice engine package tight in the back there for both. It worked out really, really well. So that packaging is what makes it really work.
And where did you find enough power to do this?
Engines are an interesting choice for a vehicle like this, since you have to be both car and plane. You have to meet EPA on the ground. You have to have enough torque and tractability in the engine to push it forward in the ground mode, and yet be able to maintain rated power at flight speeds. So it's a particular design. What we found is that the V4 from K-Tech, it's a liquid-cooled V4. If you took a V8, pulled the front 4 cylinders off to the front there, that's about what that is. It's pretty durable, pretty proven engine at this point, and that we know we can use. We are developing our own because we want to get into a certified in the future. And with that, you pretty much have to have an engine that will work for you, that you can certify. The VTEC or the V4 will not be. So we're doing another engine by Coates International. It'll be an inline 4, liquid cooled, turbo, 200 horsepower, and that produces enough for us to be able to move forward well into the future as we want to certify it later on.
And you got involved with Boeing with some kind of a pusher propeller arrangement.
Right.
And was that inspired by anything you may have seen in Reno? Was it inspired by Formula One pushers that were dominating the sport 15 years ago?
Right. Actually, it came out, I guess I was looking at a way to incorporate, I don't know if you know Bernoulli principle, but if you incorporate the fuselage as a way to shape the airflow, you can make a pocket of low-speed, high-pressure air pretty much anywhere you want it, and that's what that particular airplane came through.
You shape the tunnel as a jury.
Actually, this is for the pusher airplane, the first one that I was working with,
okay.
Boeing. It was just it ended up being a pusher, but it was a rear engine and rear propeller design, and it used the body to shape the airflow in such a way so we created that pocket I mentioned.
It looks the same as the basic idea that's behind the Samson and the SwitchBlade.
Everything we learned in there we used forward, and that we do actually do the same thing that jet engines do. They create a lot of thrust actually off the inlet. If you look at a jet engine, it's got a big broad inlet that's nicely curved, and the air that gets sucked in around that actually pulls the jet engine forward almost as much as thrust out the back. We do the same on the SwitchBlade, although we don't get as much of that because we don't have as much inlet. It's a bifurcated inlet, it's two-sided, so it's kind of got a plane in the middle of it.
Well, yeah, you have an airplane that's in the way.
Right.
And you picked a motorcycle configuration because?
It's most like an aircraft. If you're looking for something that is both aircraft and ground vehicle, you want a good match. And when I looked at all the different ways of doing that, including two wheels, the three-wheel configuration seemed the best. It seemed to be what would do the best job of any that I could find.
And the drive, let's talk about the drive system in the air and on the ground.
Sure.
You use one engine.
Use one engine. Currently it's a gas engines. In the future with electric we'll split it up into separates. But for a gas engine vehicle, we have one, goes through transmission, goes up to the prop directly, so it's direct drive off the main crank to a pulley system up to the prop. And then from there it goes into the transmission and down to the wheels for ground mode. So you're either with the wheels in the ground or the prop in the air. I think that that's the better solution. We thought about pushing it through the air with a prop on the ground, but can you imagine a guy in a motorcycle or bicycle coming up behind you at a stop sign and you floor it? He's gone.
Well, you would have a lot of throttle
Oh, yeah.
in a situation like that. Do the wheels rotate when you're in the air?
No.
They're disengaged.
They're disengaged. The basic on that, we don't know for sure on this. We could find out in testing if we want to engage them there, but we feel that because they're being run by a differential at different rates, even in the air, they'll be spinning at probably different rates. There may be an unusual yaw situation that would occur because the gyroscopic force is different on each one. But mostly because at touchdown, you don't want to have your engine engaged with the wheels contacting the pavement. That would throw a lot of shock into the transmission.
Both, whether the wheels are going too fast or too slow.
Yes, just because they're at a point where they're whatever they are, and then they're going to be stopped or speeded up to match.
Is it a single speed drive system on the ground?
No, it's actually, we have two ways of doing it. One is a CVT, continuously variable transmission, and because we're going with a little bit higher end on the one of the first, I guess, SwitchBlades out would be a very high-end SwitchBlade, and that one we can't really do a snowmobile type transmission. I mean, for normal driving that would be fine. Something you're going to spend a lot of money on, they're going to want a nice transmission. So we're having one built basically specifically for the vehicle, which is a better solution.
As an automatic or
it's an automated manual.
Okay.
So it has probably the efficiency of a manual, but
like electrically shifted.
yes. It's fairly lightweight. It's light enough to make it work.
How many speeds?
That one's 3 speeds, if I remember correctly. On that. It's three. We're looking at the fourth as an overdrive.
No reverse.
No, it does have a reverse.
With reverse.
Always will have a reverse. It's a 1,500 plus pound vehicle. I mean, you don't get out and push that.
Yeah,
not easily anyway.
1,500 pound motorcycle has
Yeah.
reverse.
Right.
Where are you right now on the development? What have you been learning? What did you have to throw away and start over?
Oh, sure. The first thing.
Those are always fun to find out.
This is really great. I thought for sure we would have a motorcycle front end. I thought motorcycle front end. It's going to have the lightest brakes, the lightest suspension possible, and absolutely that was 100% what we were going to do. We mocked up the first one. We're on Popular Mechanics front cover with that design, and we found out straight line, that's perfectly good, and stopping, perfectly good. Try cornering with a motorcycle front forks that doesn't resist side loads. A motorcycle leans in the corners. It takes all forces in line. So when we got working on it, we realized that that was not going to give the type of performance that we wanted, and so we opted for a different, more automobile style, and actually had to go through that again with a single front wheel. If you offset it like a regular automobile tire, its hinge point is to one side or the other of the tire. When you have two tires offsetting each other, that's no problem. When you put a single one up there, a left and a right turn do not feel the same. So it was pretty exciting when we got to learn a little bit about that. We actually ended up with one now that works very, very well. It's a center point steering, so we have our own custom wheel which allows center of the wheel steering. And it corners, I'd say, very well. We outperform a Jaguar XK8. Subaru WRXi is a little pocket rocket for race car enthusiasts almost. It'll almost put a Corvette to shame. But that thing had a hard time keeping up with us, so we know it's a really good handling machine.
On a skid pad or a slalom course?
This was on real world. I would say backcountry roads where you had gravel, you had all the different conditions that you face, and that was quite something.
And the acceleration that you get now with the current engine, is that adequate for ground work?
The current acceleration for ground, yes, outperformed the Jaguar XK8, the V8 power Jag. I'd say that's pretty good in anybody's book for this type of vehicle. I mean, you don't want to make it too scary.
Well, one of the questions, some of the questions I love to ask are some of the car questions. Is there a 60 time top speed on the ground? Braking distances. Have you done any of those kinds of tests?
We have. The 0 to 60 is unfortunately not a good one for us to use. Didn't when we went for that test. We broke some. So I can't give you that one. But I know we did do it. We can tell you that we went over 100 miles an hour, and actually it's very stable at that speed. It's got a very long wheelbase, and even at speeds that I never even considered driving it goes pretty well.
And with a single front wheel, how do you stop it?
It's got 3-wheel disc brakes, and they're automobile sized. It stops in a heartbeat.
What is the weight distribution when it's on the ground?
It's about equal. It's about almost 500 pounds each wheel when it's fully loaded up. And so you've got fairly equal.
It's 3367.
About that. Yeah. For a 3-wheel car with a single wheel up front, you have to keep the center of gravity to the rear.
Oh yeah.
If you don't, you'll get into an overturning situation. It's bad news. You only have to go back to the old 3-wheel
Harley trikes.
Yeah, it's Harley trike or those old ATVs that were 3-wheelers. I've ridden those. I've crashed many.
Oh yes. Well, they tip right up.
Yeah, it's
especially
horrible.
if you use brakes when you're trying to turn.
Oh yeah.
You can do silly things.
Yeah.
To the air side of things.
Yes.
What? Obviously, it features folding wings.
It does.
Among a whole bunch of other things. The tail is unconventional. Tell us about that.
The main thing with the wings and the tail, what we're dealing with in this is how do you get rid of it on the ground? Because if you want to take it with you, you have to pack it along with the vehicle. It doesn't make sense for a flying car to leave its wings or tail at the airport to have to come back for it. It cuts your usability in half, really. So what we decided to do is take it with you, but then protect it. Because if this is your lifeline, the wings, the tail, they have to function. They can't be damaged on the ground. You have to somehow protect them. So we stick the wings swing closed under the belly. They're protected by a steel keel, and then clamshell doors protect them from road grime so that they don't get damaged by rock dings or anything like that. And when they swing open, they're clean. The tail, that was a trick. We tried a lot of different things, 6 or 7 different tail designs, and it came down to how do you get the tail forward over the body or into the body and out of harm's way. So if somebody bangs you from behind or you bump into something backing up, it doesn't hurt your tail feathers, and you maybe forget about it or don't know. So those are the things we had to work with, and it led for some unusual shapes. not unaerodynamic. Actually, when I first proposed this to Darcorp, the fellows who did the aerodynamic engineering, I threw this tail at them and I said, "This is what we have. You know, feel free to change it, do whatever you want. This is what we think will work." And I expected a full, complete redesign and was ready for it. Well, they came back and they said, "Actually, you know, it works pretty good. We tweaked it here and there, but you know, it worked." So I was pretty happy with it.
So you designed the tail, you
Yes.
gave it to aerodynamicists, and they said, "Good job."
Yeah, lucky me.
Yeah.
Actually, you know, from what I could tell, it should work, but I didn't know that it would work well. And often you get into it and you say, "Okay, this works," and the engineers will tweak things and go, "Yeah, but this works better."
Of course.
And you run with it. You know, it's just what you would do. You want the best you can. In this case, they actually ran it through computational fluid dynamics (CFD), just to make sure, because it's got a different shape to it, and they wanted to make sure. So they ran it through the CFD, and it came with a little minor tweaking. It came out pretty well.
And have you done the CFD yet in different attitudes and so on, where you're skidding a turn or those kinds of things in the air?
They did
Cross controls, things
cross controls. I
things
know.
people always do.
They went beyond, I would say, I'm not going to say beyond reason, but they went beyond the norm on this tail because it is an unusual shape. And it's not something you can just point to and go, "Oh yeah, look, that'll be just fine. It looks just like a blah, 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 blah Northrop tail." It looks like nothing. So they got into military standards, actually, and designed it so that they made sure that the aircraft was stable and actually beyond anything I've seen before. So I was very pleased with what they did.
Well, let's talk construction a little bit. Is there a frameless body? Is it all composite with hard points? Is it what did you make this thing out of?
Okay, sure. Well, it's in structural engineering now, so if things change, that's the reason why. But it was originally designed as a carbon fiber monocoque with a steel keel or a metal keel up the middle, like I mentioned earlier, to take the brunt of the impacts if you high-centered over a speed bump or something, so you don't damage the wings. But essentially, you've got the hard points for the front and rear suspension, and then also for the engine. The prop mount point is integrated into that back aft end of the ducted fan. So
How
that's
do you
mostly carbon.
get the prop to be effective enough with a small? It looks like a small diameter.
40-inch diameter is fairly small. We had two people look at the ducted fan. One was Darcorp itself, but also we had what's the fellow's name now? I can't remember. I can't remember his name right off the bat, but he designs ducts for NASA and other things. He's one of the, I would say, top 3 ducted fan guys. He's at Folsom, California. I'll remember it in a second.
Well, I can do it in an email too.
Very good. Anyway, so the ducted fan design,
40-inch prop means
40-inch
you're looking at 5,000 RPM. Or a little over.
you could, but we only get about, I think we raise it up to about 3,800 RPM, and we drop it down a little bit because one of the other goals we have is noise control, noise abatement. If we're looking to introduce a lot more people to aviation and a lot more use of aviation, you can't do that and be noisy at the same time. So part of the reason of going to a ducted fan is noise attenuation. There's techniques for doing that, and that's part of what we're aiming to accomplish.
You said something interesting just there. You want to bring new people in. This isn't just for a bunch of existing pilots.
No.
How different is it going to be from flying this to conventional small light aircraft?
It is slightly different. Flying is not a problem. It's exactly the same as you find almost any other light aircraft. Takeoff and landing. Yep, exactly.
Okay.
Ailerons, flaps, rudder, elevator control, everything will be exactly the same. Landing and takeoff are different. And at first I thought, well, maybe that's a problem. But as we got in and started flying it on X-Plane, which we did to validate Darcorp's aero engineering, we saw that it's actually easier to fly. In my sense, I fly a Warrior. That's what I am prone to flying. And so I'm used to that. And you get up to a certain speed and you rotate the airplane, it takes off. And if you've got enough airspeed up and you don't rotate too hard, your takeoff is just fine. In the sense of the Switchblade, it takes off like a B-52. It's set at an angle of attack, and you just basically fly it off the runway. You don't necessarily have to rotate or should, but that is how that one's flown. Landing is, I guess, a surprise to me. When I first started flying an X-plane, and this is again just a simulator, but when I first started flying, I would do what I normally do, which is, you cut the power, you set the glide angle, and you put your flaps in, and you get it close to the, all that stuff. And one time I was flying it, and somebody came and wanted to see me, and so I had to rush. And I was just going to crash the plane to be done, but I said, I'm right here, I'll just fly it in. And so I just blazed it on in with some speed up, powered on landing, just to get done. And I realized, my gosh, that was pretty easy. And I found over and over again that if you just come in with a bit of power, you can land it anywhere between, I think I'm touching down here between 80 knots and 95 knots. Well above stall, 67. And it still lands. The reason being, the wheels are so far aft because you got the front wheel and the rear wheels, and your wings are in between. So you want that distance to be as far apart as you can to get the wingspan. So what we're doing is, that's why we don't rotate on takeoff. The wheels are too far back. They can't rotate. So on landing, what happens is you land, the rear wheels touch down, the nose goes over right away. You can't hold it up. And you're steering. You're driving now. You're done flying. So that's what we found in X-plane. We'll see how that works in the real world with our flight testing.
Well, one of the things, of course, that you have as an advantage landing like that is you have automotive brakes.
Oh, obviously.
So you can stop. You try to do that with an airplane, you burn up the wheels, you burn up the tires, you burn up the brakes. You get about halfway down the runway and you're coasting.
Yeah, right.
If you have automotive brakes and they're really hard,
right,
you can actually stop this thing. You have automotive style traction, I would guess, too. So part of that weight penalty finally starts to work to your advantage.
That part did, and it was a surprise, I'll just be honest with you, but a pleasant surprise.
Speaking of surprises, what surprise? Give me your three favorites.
If I only knew.
Yeah.
Well, let's see. Well, I already told you about the motorcycle front end. That was a big surprise. We had a really big surprise. I'll say, it was a huge moment when we first decided, okay, we're going to build a ground prototype. We're going to have this thing ready by the summer, and set a date targeted. We were approached by Popular Mechanics, and they wanted to send a reporter out. And I said, oh, that'd be great. We'll show up with whatever we have. Oh, they want to see a working model. So we said, okay, working model. We had at that point, I think, less than 3 weeks. And to the air show where we're going to have this thing at, where they wanted to come. And so we worked night and day from that point on. I don't think we left before midnight one of those days. And I had a great group. They were very good about it. They came in and just went at it tooth and nail. We got down to the last day. We'd not put the engine in yet. So we're mounting the engine on the last day towards midnight. Everything's connected up. We got a mechanic there. He's doing all his final calibrations, checking everything, making sure it's good. We're about ready to fire it up and find that it won't start. It'll turn over, but it won't start. And I'm supposed to have this at the air show tomorrow morning. So we're scrambling around trying to figure it out, and I go hit the internet trying to figure out what's up with this. We're using a Suzuki Hayabusa. This is an engine, motorcycle engine. It's really a good one. This should be no problem. And everything looks good. All the numbers are great. Well, we go to find out that there is a tip-over switch. That if it's a motorcycle, if it tips over, it stops. And we didn't have the tip-over switch. So all we had is a sensor that said, is it there or is it not? And so we had to figure that out, and that took a resistor. It wasn't just an on-off or a pair of wires that go together. It was a resistance. And so we then had to find a resistor that matched it. And we couldn't, so we got a variable resistor and just started dialing it until it fired. And we loaded it on the truck, and there you go. Popular Mechanics was happy.
You won't have that on the production model.
No, we won't have that.
That's great. And what's the timeline on being able to show something?
In the air.
Yeah, in the air would be good.
In the air is always good. We did our quarter scale testing, and that was just as we expected. And
When did you do that?
that was over this last summer and fall. The radio control model is in our booth. You can see what that is. It's a quarter scale with the ailerons and whatnot. And the full scale is in structural engineering right now. So we anticipate probably about a 12-month time span to get it up and ready and good to go. Prime time television, whatever.
So you're going to show this at Oshkosh 2014?
Yes, we'll be there 2014. We'll probably have a first flight event before then. I would expect sometime around this time next year. It's an interesting thing to build a new company, not only around a new vehicle, but just to start a business in this day and age, to do something in aviation in this day and age, and to do something brand new in this day and age. And I think that's something that I kind of like the challenge of it. I kind of like to be able to say, I did that. And the team is also really excited because if we can do it now, we can do it anytime, anywhere. And I think that's a pretty good way for a team to think, that they can do anything at all that they're asked. That's my team.
I think that is neat because I think you're probably a little short on institutional encouragement right now.
Yes, the banking industry,
governmental,
well, they'll buy in.
regulatory,
Yeah, they'll take 75%. You know, you want to, half what you need. Well, 75% of your company's totally fine. But we've had a good bit on our own. We funded a lot of it ourselves. The last little bit has been through people around the world who have been following us for years now. Look at it and say, look, I want a SwitchBlade, so count me in, let's get this done. And that's really nice to see. It's really great to have that kind of support.
But you're not taking customer deposits.
We're taking refundable deposits to an escrow account, sure.
Okay.
They're refundable, that's $500. So $2,000 deposit.
But these customer donations are something else.
These are people who had either signed up for a deposit and wanted, or have been looking to do that, and decided, you know what, we had a program where we said, hey, come in now, we'll give you a great discount. The money is not escrowed, we have to take and use it, but it's going to be used towards producing the flying prototype that everybody wants to see. And that got a lot of people's attention.
Are you able to talk about how many people that is, or how much money you've raised that way, or anything like that?
Yeah, we did 15 people who signed up for that program. Several more that wanted to, but that was as much as we needed to get forward. We already had a lot of help from suppliers and laborers who want to work for us after this is done and going, so they're donating labor and materials. And so our raise is actually fairly minimal from this point forward. It was about, roughly $500,000.
Okay. What do you want me to ask you that I didn't ask?
Let's see. Why are we here at
why are you
LSA country? One of the reasons we came to the LSA Sebring, and it's more than that, but that's a lot of what it is. We started out wanting to be a light sport, knowing that was probably where we were ending up if we didn't start out that way. But as we got into the process of building a new airplane from scratch, we looked at the rules of light sport and realized that's going to be a tough one. In order to do a flying car and make it fit within that box of light sport looked like a pretty daunting task. And my hat's off to Terrafugia for doing it, because I think that's a pretty tough one, harder than we're doing. We started an experimental because at the end of the day, pretty much you can make it an experimental as long as you keep pushing. Sound engineering, not a crazy idea, push it forward. You can get to an end result, but can it meet LSA rules? That's a tough one. And so here at Sebring, we came to find out if we were to do an LSA, what would people be interested in? What makes sense to them? What do they not want to see? Those kind of marketing questions. So that is why we're here mostly. Also, we haven't been to an event since Oshkosh and we kind of miss it.
If you decide to go LSA, can you get the same weight penalty deal that Terrafugia got?
I believe so. Maverick did. We're all in the same boat, having the extra weight for use on the ground. Even though we're not subject to the same rules as a four-wheel drive car,
Right, that's
a four-wheel
what I mean.
car.
You're a motorcycle.
We're a motorcycle. We don't have to meet some of those requirements. But to be honest, when we started off, we recognized that, but we also recognize it's fully enclosed. People sitting in it are going to feel as safe as a car. And if that's their mindset, we better make it as safe as we possibly can, regardless of the rules, because people are going to drive it that way.
At least there's the weather protection.
There's that.
That's what you are protected from.
That's true.
Anything else, you might as well be in a nice setup.
Well, I don't know. We have front rear crash zones. We have side impact door guards.
Yeah, that's a lot more modern than the last one.
Yeah, we have lap belt for the crash belt, crash. I forget what they call it. That one you
For
can
impact
strap.
testing and so on.
Yeah. Inflatable balloons with pop airbags. There we go.
Are you looking at an unsafe type of a system? Or
AmSafe is one, and there's actually a dedicated system that we'd like to include if we can get the manufacturer to play ball. We use that.
have you found out what you're trying to find out about the LSA market, or is it too early in the show?
No, it's too early. I think I'd like to see a little bit more surveys. I think it's definitely there. I think the interest is there. There's a lot of people that want to keep flying. A lot of new people in aviation that light sport is an easier way to get in. I think it's definitely worth a go. I think your cost is where it really boils down. You have to bring it in under a certain cost if you're going to make it in that kind of a market. We do have a material choice that we're looking at that would enable us to bring it down to in that cost range, and that's part of what we're doing, is actually looking not only at the marketing, but also how do you build aircraft in such a way that it doesn't cost as much as it costs today.
Well, if you have a two-seat LSA that costs as much as an SR-22, it's not going to sell.
Yes.
So you can't sell it for $600,000.
Right.
Do you have a price point in mind?
We don't at this time. I could just say that it's got to be competitive. Maybe our initial ones wouldn't be because you're starting up at low volume. I don't see how that would pencil, but our end goal is to be very competitive on price and get the user numbers up. I mean, if you're trying to bring more people into aviation, you're not going to do it by appealing just to the upper limit of expenses. That's a way to start, but you can't get to where that goal would take you if that's what you're going to do.
Will it be easy enough to fly that a newbie can learn? Would this be something they could train in if they bought it?
Yeah, especially like in experimentals, if you own the vehicle, you can train in it.
Right.
We're setting it up with a possibility of dual controls. In other words, setting it up so that you can slide in a second set of controls for the CFI, Certified Flight Instructor, so that he feels safe in guiding you. And we're trying to do that on you would call it a loaner basis or a lease basis, because you're not going to need it all the time. You're just going to use it to fly in, and then you're going to have no need for it. So we would have actually it'd be their machine. They could build and drive it and have it in the meantime. Learn to fly in exactly the vehicle they're doing. When they're in flight mode or flight training mode, they would just slide in the extra control wheel and the extra rudder pedals, and the flight instructor would use the handbrake for the brake in the middle, and he's set up. He or she would be able to guide the person and feel confident that they've got control of the vehicle at all times.
Would the yoke also control the ground steering?
It does. That's a little bit tricky for us to work out.
I was going to ask you how you do that. Yeah.
That was
especially if you're going to slide a yoke in.
Yeah. So we have to have a lever that when we engage the lever, it disconnects the grip on the yoke, so it allows it to go in and out for flight mode. It unlocks the wings and tails so that it can be hold out for a flight and then they lock in place again. And it actually acts as a signal to flip the avionics from one mode to the other, because obviously on the ground you need ground instruments. In the air, you're operating on air instruments. Dynon has been nice enough to, since we're looking at using their SkyView, they've been nice enough to allow us to go in the future here. We'll be rewriting a page and putting a page on top of what they have, so that we can have all of their stuff plus our ground on the display.
What ground instruments do you need that you wouldn't have in the aircraft?
Well, your RPM, not necessarily have that in the air, but you could. You would.
You have to have a TAC in an airplane.
That's true. You're right. I think that mostly it's just the presentation. The Dynons are over on the side, and we're going to have a slave screen or another screen that's up front, right from the yoke.
GPS speed, perhaps, even on the
Yeah,
ground?
you'll have a ground
You can get one
GPS.
for that.
Yeah, you have ground GPS. We'll have just the normal instruments you'd have. Less.
Turn signals.
You don't need a turn and bank indicator and a lot of those things
No.
on the ground, so you'll have those types of things. So just the RPMs, the speedo, odometer.
Or your usual ethos system, your usual engine.
Yeah, you could have that
monitoring,
still.
You could have that on the ground just as easily.
Yeah.
Same instruments.
Yes.
Same red lines.
Exactly.
It's all the same stuff. You just operate it differently.
Right.
But let's backtrack just a little bit with the engine on the ground.
Question again, real quick. Go ahead.
Okay, I want to backtrack a little bit and ask about the engine. Obviously, on the ground, you need something that will go from idle to acceleration to cruise, which will be a low power setting,
Yeah.
back to full power for more acceleration, back to idle. But in the air, you're at full power, cruise power, or what you might call landing power,
Yeah.
which is enough to keep the propeller turning.
Right.
How do you get all of that in one engine? And how do you engineer that engine control system to be efficient and actually work?
Yeah, that's a good trick too, and we'll find out a little bit more as we get into flight testing and prove it out. But what we've done right now is to get an engine which is light enough and powerful enough to derate it slightly. And that's where I think where you can get your 70% continuous power, is you're not pushing the engine past what it can really do. A lot of engines, like the V4 engine that we're dealing with, it's capable of 8,000 RPM, but we're down there at 5,000. You know, it can go all day at 5,000, so 75% power is not a problem for you. On the controls, and what you're trying to do with them, they are completely different. You need rapid response on the ground. In an aircraft, you want something that's settable and leaves. You know, you push it to a point that stays there. And so those...
You don't want it moving around.
Yeah, you want it to stick around with you. So those are actually two sets of controls on the SwitchBlade. There is a gas pedal for the ground, but it's overridden by a lever control, which is the aircraft control. And the aircraft control basically pushes past the input points of the gas pedal down below. And that's how you operate it. Then you have a traditional aircraft type power setting for air use, and when it's idled back to zero, the gas pedal takes over and it does its job. So that's as close as we can come at this point. We'll know more a little bit later.
Anything else you want me to ask you?
I think that's a pretty good interview. Appreciate it.
I think it was pretty compact.
Yeah.
Thank you.
Well, you bet. Thanks a lot for stopping by. So,
Cool.
good deal.
And that's a wrap for now. We'll be back when it's flying.